In this video, we are going to see the shortest job first, that is SJF scheduling in operating system. Shortest job first scheduling algorithm, or we can say shortest job next, that is SJN, or we can say SJF. In this algorithm, the process with the smallest execution time gets executed next. This reduces the average waiting time for other processes significantly. There are two types of this SJF. First one is the preemptive SJF and another one is the non-preemptive SJF. In this video we are going to see only the non-preemptive SJF, or simply we can say that as SJF. Preemptive SJF is also known as the shortest remaining time first algorithm. That we are not going to see in this video. We are going to see this SRTF in the next video. In this video, we are going to see only the preemptive form of this SJF, or simply it is called as SJF algorithm. What is a non-preemptive SJF? It is that the CPU is held by a process until the process reaches the waiting stage or terminates. That is, once a process gets hold of the CPU, or once the process is gets the CPU for execution, it is completed. It is completely executed. It is not preempted in the middle. That is known as the non-preemptive SJF. We can see this by an example. Consider 5 processes, that is in the tabular column it is given in a table, that is from in the process queue. The process P1, P2, P3, P4, P5 are there. Their burst time and their arrival time are given. That is, first at time 0, P4 arrives and starts executing. Then at time 1, we can see from the table process P3 arrives in the waiting queue, but P4 continues executing as it needs to complete 2 more units. At time T2, P1 arrives in the waiting queue, but P4 continues executing. Since it is a non-preemptive approach, P1 continues executing without any preemption. At time T3, time 3, P4 finishes the execution and P1 starts executing as it has the least burst time. At time 4, P5 arrives in the waiting queue while P1 executes. Then at time 5, process P2 arrives and enters the waiting queue. P1 will continue its execution. And then at time 9, P1 finishes its execution, and after comparing the burst time of P3, P5 and P2 in the waiting queue, P4 with the least burst time starts executing. That is, at time 9, P1 since it has 6 units of burst time, it completes only at time 9. And then after comparing the process based on their burst time, P2 is having the least burst time of 2, so it starts executing. Then at time 10, P2 continues executing while P3 and P5 are in the waiting queue. Then at time 11, P2 finishes execution and P5 starts executing. Then at time 15, that is P2, then P5 has its burst time of 4, so from 11 to 15 it executes and then it finishes its execution. Then P3 starts executing. Then at time 23, P3 finishes its execution. Since it has its burst time of 8, at time 23 only it finishes its execution. Here Gantt chart is given where P4, where the Gantt chart we know it is the graphical representation for the scheduling process, where P4 here comes first, so it executes up to 3, that is it has the burst time of 3, so it executes up to 3 units of time. Then P1 arrives, so it holds the CPU, it executes for it completes at 9. Since it is a non-preemptive approach, then P2 executes, then so on up to P3, which completes its execution at 23. Then based on the formulas for turnaround time and waiting time, turnaround time for process P4 is calculated as that is completion time 3 minus, that is from the Gantt chart we can calculate, then minus arrival time, this is from the table we can see. And say similarly waiting time for the process also is calculated, and it's given. For P4, it is turnaround time minus the burst time. Since for P4 it is 3, the turnaround time is 3 and burst time is 3. We can get we are getting the answer at 0. And so likewise, if we calculate for all the processes, we can get the waiting time for all the processes, and from that average waiting time is calculated as 5.2. Coming to the advantages and disadvantages of SJF, it is optimal for minimizing the queue time. And then its average waiting time is minimum for amongst almost all the scheduling algorithms. That is the preemptive version of SJF will have the minimum waiting time comparing to all the other algorithms. Then disadvantages, it is challenging to implement in the interactive systems as we don't note the CPU time prior. Here coming to the disadvantages of this non-preemptive SJF approach, different processes arrive at different time for execution. Then sometimes the process which has shortest burst time will have to wait so that the current process can finish its performance. The reason behind is that we know that it is the non-preemptive mode, as in this the current process is not halted in between the arrival of shortest burst process. So this is the disadvantage of this non-preemptive approach. Subscribe to my channel if you feel contented.